There's two men, P and Q, stand close to the gap in a wall. So there's a gap in a wall there. Two men, P and Q, as shown. Man P cannot see man Q, but man P can hear man Q speaking. Which statement explains this? Now you must understand, and it should get into your head, that when waves spread out into regions that they were not expected to spread out after passing through a gap, then that's what we call diffraction. But here's the thing. You must understand that diffraction is affected by wavelength. The bigger the wavelength, the bigger the diffraction. The lesser the wavelength, the lesser the diffraction. So here, the question is asking you, man P cannot see man Q, meaning that for you to see, you see because of light waves, meaning that light waves from man Q are not reaching man P even after passing through the gap, meaning that there is not enough diffraction for light waves from wave Q, from Q to diffract. There's not that much diffraction to man P. But man P can hear man Q speaking, meaning that sound waves are able to reach man P, meaning that after passing through the gap, the sound waves are able to spread out to man P, meaning that sound waves are being diffracted more than than light waves. So the question asks you, which statement explains this? A, light waves do not diffract at all because they are electromagnetic waves. This is a wrong statement because all waves diffract. It's a property of all waves to diffract. Then B says light waves have a range of frequencies, but sound is just one frequency. Again, wrong. That is very wrong. Sound, people can sing at different frequencies. The reason why your voice is different from my voice is because of our frequencies, our pitch. C, sound waves are of a higher frequency than light waves. This is wrong. Light waves have a bigger frequency than sound waves. Then finally, sound waves diffract a lot because their wavelength is similar to the width of the gap. This is more correct. But to further this point, the sound waves diffract a lot because their wavelength is similar to the width of the gap. But the other issue is that the light waves have got a wavelength which is so small compared to the width of the gap there. So the reason why sound waves are diffracting is because they've got the bigger wavelength, ultimately. Okay, so the next problem question was number 25. Which statement describes the direction of an electric field at a point? Now, direction of an electric field is where a charge experiences an electric force, a repulsion or an attraction. So a charge is experiencing a repulsion or an attraction, then it is in an electric field. So the question is asking you, what do we know about the direction of an electric field? The direction of an electric field, if you see arrows like this, and these arrows are representing the direction of an electric field, they are simply telling you that if you were to place a positive charge here, it would experience a force in this direction. So that is the direction of an electric field, the direction that a positive charge placed at that point would experience. So the answer is C. 26. Which statement about a voltmeter is correct? It measures potential difference. There is no need to worry about that. Number 27. A wire has a resistance 8 ohms. A second wire has the same metal and twice the length and twice the cross-sectional area. What is the resistance of the second wire? Now you must understand, because this question will always come in every paper, resistance is proportional to length. Resistance is inversely proportional to area. Now, by resistance being proportional to length, it means that if length is doubled, the resistance is doubled. If length is tripled, resistance is tripled. If length is halved, resistance is halved. But the opposite is true for area and resistance. If area is doubled, resistance is halved. If area is tripled, resistance is divided by 3. If area is halved, resistance is doubled. If area is divided by 3, resistance is multiplied by 3. So a wire has a second resistance of 8 ohms. As a resistance of 8 ohms. A second wire of the same material has twice the length. So by having twice the length, it means that that would double the resistance to 16. Number 1. And twice the cross-sectional area. Remember, I told you that if we have twice the cross-sectional area, if the area is doubled here, the cross-sectional area, this halves the resistance. So this one, which had become 16, then is halved, divided by 2 to become 8. So that's why the answer there is 8.